Okay, student, let us see the question number 47. Okay, so question number 47 is about the for the network shown in the figure. A steady state is reached with the switch K is open. Okay, so switch is closed at time t equal to 0. Calculate di1 by dt and di2 by dt at t is equal to 0 positive. T is equal to 0 positive 100 volt 10 ohm. So this is given here. Question number 47. Yes, question number 47. So this is my question number 47. So this is about the network is given. This is positive negative positive negative. Okay, so this is my resistance and this is my resistance here, inductor. Okay, so this is my resistance, inductance, and this is my resistance and this is my capacitance. Okay, so and this is my switch here. This switch is connected like this. So this is my switch. Okay, so this switch is connected at t is equal to 0. Okay, so t is equal to 0 and this is inductor. The resistance, this is 20 ohm and this is my 2 microfarad and this is my ground and this is 20 ohm and this is my 2 Henry and this is my I1 of current. Okay, so I1 of current and 10 ohm and this is my 100 volt and this is positive negative. So this is what 2 Henry 20 ohm 20 ohm. Okay, so asking what about di1 of 0 positive by dt and di2 of 0 positive by dt is equal to what? Yes, so these are the two current. This is my I2 current and this is my I1 current. Okay, so let us just solve this first. What we will do first? So let us see when this switch is open. Okay, so let us first for t less than 0, for t less than 0 for very long time, for t less than 0 for very long time, very long time. What we can say about this? For very long time, for t less than 0, circuit will reach to its steady state. Okay, so just wait. Sorry for interruption. So this is for t less than 0 for very long time. The circuit will circuit will reach to circuit will reach in. Okay, so circuit will reach at steady state. Okay, so here the circuit will reach to steady state value, steady state. Okay, steady state. Circuit will reach to steady state where inductor will get short circuited and capacitor will get open circuited. Okay, so this inductor will get what? Short circuited. Okay, short circuit and this capacitor will get open circuited. So this capacitor will get open circuited at steady state. Yes, at steady state, that we know very well. Yes, so we are understood about this. When the circuit will reach to steady state value, then always the inductor and capacitor will what? Inductor will get short circuit and the capacitor will get open circuit. Okay, so because in steady state means what is? It's a condition like a DC. Yes, it's a DC condition. So for which the capacitor will get open circuit. DC is nothing but the frequency is 0. Once the frequency is 0 means capacitor impedance will become infinite and the inductance impedance will become almost 0. Okay, this is all about. So let us see here. This is my voltage negative positive. This is 100 volt, 100 volt. Yes, 100 volt, and this is my resistance. Yes, and this is my resistance, and this is short circuited, and this is again my resistance. This is open circuited. Okay, so this is my I1 of 0 negative. This is VC of 0 negative. Yes, and this is my 20 ohm, and this is my 20 ohm, and this is my 10 ohm. This is my 10 ohm. 10 ohm. So let us see here. Apply the voltage division rule. Okay. So apply here by voltage division rule. Okay. By applying by applying by applying voltage division rule, VDR. By applying VDR here, what we will get? Vc of 0 negative is equal to 20. 20 into what? 100 divided by how much? 10 plus 20. So this is what? 2000 divided by 30, which is nothing but 200 by 3. What? Volt. Okay. So this is what? Vc of 0 negative is equal to what? 200 by 3 volt. Yes, 200 by 3 volt. Okay. So this is my Vc of 0 negative, and here Ic of 0 negative. This IL of 0 negative is equal to how much? 200 by 3 by 20. So by 3 by 20. So it become how much? 2 get cancelled, 2 get cancelled, 10 by 3 ampere. Yes. So this is my IL of 0 negative is equal to 10 by 3 ampere. 10 by 3 ampere. Yes. So this is my these are my initial value of about this circuit. Okay. So initially the circuit is not relaxed from here, we can say, because the source is connected here, through which this inductor and capacitor get charged. Okay. So therefore these are my initial conditions. So now let us move forward. So let us move when the switch is connected to what? When the switch is connected at t is equal to 0. Okay. So let us connect this switch. Okay. So connect the switch first. This is my Vc of 0 negative, 200 by 3 volt. This is 10 by 3, 200 by 3, 10 by 3. Okay. So that we have obtained. Okay. So now see here for next. So what is about when? First. So see here next for t is equal to 0 positive. Yes. For t is equal to 0 positive. Let us see here positive, negative. Okay. Now see here. So this will get switch on. So therefore it will get short circuited. So because if you see here, this is resistance and this is switch is connected, means this is what? Voltage is 0 volt, here 0 volt. So this means what? Current passing through is 0 ampere. So this means what? This is all the current will pass through this one. Okay. So no current will pass through this. So it's like open circuit. Okay. So this is like this. So it is almost like short. Yes. So therefore this is what? Resistance, and this is inductor. Inductor will get open circuited at what? At inductor will get open circuited at t is equal to 0 positive. Yes. So this is positive, this is negative, this is 100 volt, and this is what? 20 ohm, and this is resistance. Okay. So this is my positive negative voltage. Yes. So here this is how much? This is my 200 by 3 volt. Okay. So this is short circuited, and this is my 20 ohm. Yes. So this is my VL of 0 positive. Yes, positive, negative, and this is how much? 10 by 3. So now VL of 0. If you see here, now by applying KVL through this loop. Okay. By applying KVL through loop 1, so what we will get? By applying KVL. Okay. By applying KVL in loop. By applying KVL in loop 1, we get what? We get here 100 what? Minus 100 minus here 20 into 10 by 3 minus VL of 0 positive is equal to what? 0. So this is what? 100 minus 200 by 3 is equal to how much? VL of 0 positive. Yes. So 3 minus 2 is 100. So this is my 100 by 3. So 100 by 3. So this is VL of 0 is what? L1. So di1 by dt. 0 positive. Yes. So L1 is how much? 2 Henry. So therefore this L1 will go that side. So this is my here let us right here di1 of 0 positive by dt is equal to how much this will go that side. So this is my 100 by 3 into L1 is how much? See here 2. So this is 2. Okay. So this is 2. So this is nothing but 100 by 6. Okay. So di1 this is 100 by 6 ampere per second. Okay. So di1 of 0 positive by dt is equal to how much? 100 by 6 means 50 by 3. Yes, ampere per second. So which is nothing but 16.67 ampere per second. Yes, ampere per second. So this is my first I1. So this is my first what? di1 of 0 positive by dt. Okay. So this is for di1 of 0 positive by dt. So now we are going to solve for IC2. So this one current. Yes. So how we can calculate this one? So let us see first. First this we will solve by what? So let us, this is what? This is okay. So now see here for this, for I2 what we will do, we know what? We know VC of what? VC of 0 positive or negative, both are equal because we know very well. So this is what? 200 by 3. What we know very well, that voltage, that capacitor does not allow the sudden change of voltage across it. So then that's why VC of 0 positive equal to VC of 0 negative equal to 2 by 300 volt. Okay. So similarly the current, that inductor does not allow the sudden change of current passing through it. So that's why IC of 0 positive is equal to IL of I1 of 0 negative is equal to I1 of 0 positive. Okay. So now see here, this is what that we have obtained. Okay. So let us see what for, let's see for t less greater than 0, for very long time, for very long time, what we will see here, for very long time the circuit become like this, positive negative, and this is my short, and this is what? Resistor, and this is also short, because for very long time inductor will get short circuit. Very long time means circuit will reach to what? Its steady state. Yes, its steady state. So therefore here resistance, and this capacitor will again open circuited here at what? At steady state, because finally it will reach to steady state for very long time. Okay. So now this is my VC of infinite. What? VC of infinite, and this is my 20 ohm, and this is also my 20 ohm. Okay. So this is my 100 volt. So now see, if you see here VC of infinity is how much? VC of infinite is nothing but VC of infinite is how much? 100 volt. How much? 100 volt. So VC of infinite is 100 volt. Okay. So VC of infinite is 100 volt. So now we know final value, we know initial value. Then the only thing that we don't know is about time constant. So that also we can calculate from here. The time constant is how much? Time constant tau is equal to RC. So how much is R20 and how much is C2 microfarad? Okay, 2 microfarad, 10 to the power minus 6. This is 40. So this is 40 into 10 to the power minus 6 second. Yes. So this is my time constant. This is my what? Time constant. Okay. So just wait. Okay. So this is what time constant is. Time constant is how much? 40 microsecond. Okay. So this is my 40 microsecond. You can say this is about 40 microsecond. Okay. So now see here. Just what we will do here. This we have solved. Okay. So just remove this from here. Okay. So like this. See now. Tau. Okay. So tau we have calculated. We know final value, we know initial value, we know tau. Okay. So therefore for t greater than 0. Okay. This is my third. For t greater than 0, VC of what? VC of t is equal to what? VC of t is equal to VC of infinity. Vc of infinity plus Vc of what? 0 positive minus Vc of what? Infinity into e to the power minus t by tau. Yes, e to the power minus t by tau. When you will see this, solve this. So Vc of t, here if you see Vc of t is how much? Vc of infinity, let us see here, Vc of infinity is 100. So this is my 100, this is my 100 plus if you see plus Vc of 0 positive is how much? This is 200, this is 200 by 3, 200 by 3. So this is my minus infinity 100 into e to the power minus t divided by 40 into 10 to the power minus 6. Yes, 10 to the power minus 6. So that you can also solve. So this is my expression for this. Yes, Vc of t is equal to how much? If you see 100 plus, if you see 200 minus 300 is minus what? Minus 100 by 3. So let us first see, this is 100. Okay, 100. Okay, so this is 100, so this is nothing but 100. Okay, so 100 by 3 into e to the power minus t by 40 into 10 to the power minus 6. Yes, so let us see, is it visible? Okay, somewhat it is visible. So it is what? 100. Okay, so 100 by 3. So what we can write here? Vc of t is equal to how much? 100 take common. So this is nothing but 1 minus 1 by 3 into e to the power minus t divided by what? Divided by 40 into 10 to the power minus 6. Yes. So this is what? This is my Vc of t. Yes, Vc of t for t greater than 0. So this is for t greater than 0. So now see here. So this is my I2 of t. Yes, I2 of t. So what we will do now here? I2. What? I2 is equal to what? dvc of t by dt. dvc of t by dt. Okay. So let us remove this first. Let us remove this also. So this is what? I2 of t. Yes, this is actually I2 of t. Yes, I2 of t. I2 of t. I2 of t is equal to how much? C is how much? 2 microfarad. 2 microfarad into C d by dt. d by dt of what? d by dt of what? Vc of t. Vc of t is how much? 100 into 1 minus 1 by 3 into e to the power minus t by 40 into 10 to the power minus 6. Yes. So this is what? This is nothing but d by dt. So if you will differentiate this, what we will get? 2 into 10 to the power minus 6. This is 100. This is 0. Okay. So d by dt. So minus plus. So you will get here 0 plus 100 into 1 by 3 into 40 into 10 to the power minus how much? 6. Yes, into minus t to the power minus, this is 40 into 10 to the power 6. Yes, so if you see here, what you will get? 2, this will get cancelled. Okay, so what is other? 2, this 20. Yes, you are left with 100 by 60. 100 by 60. So this is 100 by 60. Okay, IC of 2. Okay, just wait. IC of t is equal to C dvc by dt. C dvc by dt. Okay, so this is nothing but e to the power minus t by 40 into 10 to the power minus 6. Yes, minus 6. Okay, so this is my e to the power, this is my I2 of t. Yes, this is my I2 of t. Okay, so this much. Okay, so how much is this? 10 by 6. 10 by 6 means 5 by 3 into e to the power minus t by 40 into 10 to the power minus 6. Okay, 10 to the power minus 6. This is my ampere. Yes. So this correct. This is my I2 of t. So that is, see, I di2 of t by dt. How much we will get? Di2 of t by dt. T by dt is how much? So just differentiate this. What you will get? 5 minus 5 divided by 3. 3 into 40 into 10 to the power how much? Di2 of t by dt. Yes. So just wait. So this is my 100. Okay. So C dvc by dt. C dvc by dt. Differentiation of this become this. Okay. So what about this? So this is what? 5. 3 into 40 into 10. Okay. So in 3 into 40 into 10 to the power minus 6. Minus 6. This is minus. So it is e to the power minus t by 40 into 10 to the power minus 6. Okay. So this is my di2 of t by dt. Okay. So let us see this equation. Okay. So now see, we are just closer to our final answer. So this is nothing but, let us see here. So let us see here, di2 of 0 positive by dt is equal to how much? Just put 0. So this is nothing but minus 5 by 12, 5 by 12, 5 by 12. Okay. So this is 10 to the power 5, 10 to the power 5 ampere per second, ampere per second. So 12, 5. If you see here, what is 12, 5? How you can divide this? So this is minus 50 by 12 into 10 to the power 4 ampere per second. So which is nothing but 12, 4 the 48. So this is minus 4.2. So there is what? 2. Okay. So 2. So 12. So 12 means what? This is means 25 by 6, 4, 1. So means 12. So this is 3, 4. 2 is there. 12, 1. Yes, 1. 12 and the 12. Okay, so 1, 8. 8 means what? 7, 6. Yes, 6. Okay, 6 into 10 to the power 4 ampere per second. Yes, so it will come what? Approximately equal to 4.167 into 10 to the power 4 ampere per second. Yes, 4. So this is my final answer for di2. Yes, for di2, and this is my final answer for di1 of 0 by dt. So these are the answer. If you will see, the answer is what? About, this is minus 4.167. Option A is correct. For this, option A is correct. Yes, option A is correct. Yes, option A is correct. So now let us move for question number 48. So this is about question number 47. Okay, so answer is di1 of 0 positive by dt. So this is 16.67, and this is di2 of 0 positive by dt, and this is minus 4.167 into 10 to the power 4 ampere per second. Okay, so just in second case we have applied the condition for final. Yes, final and initial condition. Okay, we have found final value, we have found initial value, but in case of first, we just stopped at t is equal to 0 positive only. So there only we got the answer, because here inductor, for inductor we have applied here KVL, through that we got this answer. So but little bit we have explored somewhat more for this capacitor, for this current I2. Okay, so that is all about this question number 47. Okay, so let us move for question number 48.